In this video, you will learn how to answer questions where you use forces and kinematics together. And now if you understand forces and you understand kinematics, then this will not be difficult, because most of the time you're just using forces to solve for the acceleration, and then you're plugging that acceleration into your kinematic equations. And now there could be different variations of this, where you use the kinematic equations to find the acceleration, and then plug that into your Fnet equations to solve for a specific force. But truly, if you have a good understanding of forces and kinematics by themselves, then it won't be difficult to use them together. Let's do an example to practice this. In this question, we have a 900-gram rocket, which we will launch straight up. And the goal is to hit a horizontally moving target as it passes 40 meters above. We are told that the rocket engine provides a thrust force of 15 newtons, and the target is moving at a speed of 15 meters per second. And we want to know at what horizontal distance between the target and the rocket should we launch the rocket. Now the first thing we want to do is write what was given. We will look at the rocket and the target separately. Starting with the rocket, we know its initial position is 0 meters because it starts on the ground. Its final position will be 40 meters because that's when it strikes the target. Its initial velocity was 0 meters per second because we hadn't launched it. Its mass is 0.9 kilograms, and the thrust force from its engine is 15 newtons. Now looking at the target, we were told that the target is moving with a velocity of 15 meters per second. And now the target is moving with uniform motion. So we can use the uniform motion equation, which says v is equal to delta x divided by delta t. And we know v, we're solving for delta x, but what we're missing is delta t. So what we're going to do is we're going to use the information we have for the rocket to solve for delta t. And now based on what we have for the rocket, we should use this kinematic equation to solve for delta t. Because we have the final position, we have the initial position, we have the initial velocity. But what we're missing is the acceleration. But we can find the acceleration if we use forces. So I will draw a quick free body diagram to represent the rocket. We know we have the force of gravity pushing down on it and the force of thrust from its engine. And Fnet would be pointed up because the rocket is accelerating up. The next thing we will do is write our Fnet equation. So this would be the sum of all the forces acting on the rocket. So we have Fnet is equal to the thrust force minus the force of gravity. And remember, the force of gravity is negative because it's a vector that's pointed down. We can replace Fnet with ma, we can replace the thrust force with 15 newtons, and we can replace the force of gravity with mg. And then all I need to do is rearrange this equation to solve for the acceleration. Once I've done that, I can plug in all my values, and we find that the acceleration of this rocket is equal to 6.9 meters per second squared. And now that we have the rocket's acceleration, we have everything we need to use our kinematic equation to solve for delta t. So all I need to do is plug in my values and then rearrange to isolate for delta t. And when we do that, we see that delta t is equal to about 3.4 seconds. And now that we have delta t, we have everything we need to solve for delta x in our target's uniform motion equation. So using the v is equal to delta x divided by delta t equation, I can rearrange and isolate for delta x, plug in my values for v and delta t, and we find that delta x is equal to 51 meters. That means the distance between the rocket and the target should be 51 meters when we launch the rocket up. And that's how you use forces and kinematics to solve questions when an object is in motion.